How do children learn language? Learning outcomes. After reading this chapter, you'll be able to describe the challenges children face in learning language, understand key features of child language development, explain the strategies children use to learn sound, words, and grammar. Introduction. Despite language being an extraordinarily complex system of sounds, grammar, and meaning, children the world over have mastered many of its intricacies by their 5th birthday. In a few short years, children go from no language to babbling, to producing their first words, to stringing words together into sentences, to holding conversations and telling stories. Ibbotson, 2022. Children learn to use the power of language to form relationships, communicate their most personal thoughts, imagine the future, remember their past, and cooperate with others. The basic nuts and bolts of all these abilities are acquired in under 2,000 days, with a large proportion of that time spent asleep. Language is also the primary channel through which children learn about culture, and it is a powerful cultural tool in its own right. By calculating back from the average adolescent vocabulary, we can estimate that children must be learning about one new word every 2 waking hours. From when they begin speaking, contrast the apparent ease with which children learn language with the effort it takes to learn an additional language. As an adult, and this raises a question, how do children, who are generally thought to be less skilled and knowledgeable than adults, acquire such a complex system as language at such a young age? This chapter is about how children acquire that incredible aspect of our human nature. Early Learning Center. Language learning certainly begins early, at 35 weeks old. Babies can already distinguish between different vowel sounds. That is not 35 weeks after birth, but 35 weeks after conception. While they are still inside the womb, the wall of the mother's abdomen and the amniotic fluid absorb the higher range frequencies of speech coming from outside, reducing its volume by about half. For that reason, parental infants hear vowels better, which are louder and lower pitch than consonants. By week 37 of pregnancy, prenatal babies show a preference not only to listening to their mother's voice, but also towards any speaker of their native language. Kiskelevsky et al., 2009. In one study, shortly after birth, babies were fitted with headphones and heard either a story their mother had read to them twice a day in the last 6 weeks of pregnancy, or an unfamiliar one. The babies could change the story they heard by either sucking faster or slower on a dummy in their mouths. Most newborns sucked the dummy at a rate that caused them to hear the story they had heard in the womb. D. Casper and Spence, 1986. Impressively, they showed that, while only days old, these infants both recognized the story from the womb and were able to change their behavior, sucking rate, in order to satisfy their preference for a familiar story. In the first months of life, babies are able to tell apart most, if not all, of the sounds of the world's languages, some 600 consonants and 200 vowels. Tiseo, Patel, 2004. Despite being born equally able to learn any of the 7,000 different languages, infants soon home in on the language they are exposed to, at the expense of those that are not. Many studies have shown that young infants can distinguish a wider range of sounds than is present in their native language, but they lose their ability somewhere between 6 and 12 months of age, e.g. Worker and Tees, 1984. For example, Japanese learning infants soon have trouble distinguishing between English L and R. Not an important distinction in Japanese, but it is in English. Likewise, English learning infants soon have difficulty with Arabic sound, which is similar to the English H, but with a small puff of air released along with it. An infant sound in Arabic, but not in English. This narrowing of what sound children respond to is another example of a sensitive period in development, first introduced in Chapter 2. It is if children hedge their bets that if they haven't heard examples of a particular language in the first 6 to 12 months, then there is a good chance it isn't a significant part of their culture they are born into, and so it's better to concentrate on learning a language that is. This effects of the early bet hedging are not limited to language either. For example, Kelly and colleagues, 2007, tested 3 to 6 and 9-month-old infants' ability to distinguish faces within their own ethnic group, white Western versus 3 other groups, African, Middle Eastern, and Chinese. The 3-month-old could distinguish faces in all conditions, but by 6 months old had narrowed it just down to white Western and Chinese faces, and by 9 months old, successful differentiation was restricted to only own ethnicity. The more general message is that in the first year of life, children are involved in a significant period of sensitization to their family and cultural surroundings, of which language forms a key part. Key point. Before birth and after, children are becoming sensitized to the sounds in their native language and insensitive to those that are not. Insensitive to those that are not. Where are the words? We are so familiar with seeing the spaces in written text and hearing a sequence of separate words that it is easy to forget that in reality speech is much more like a pulsing stream of sound. Sometimes the pauses in speech line up with the boundaries of words, but often they do not. This becomes apparent if you hear someone talking in a foreign language, or if we represent language in a format like a spectrogram that more closely resembles the input into our ears. Have a look at figure 4.1 and see if you can figure out where the words are. Neither the overall volume, the pauses, nor the acoustic frequencies are reliable cues to the word boundaries on their womb. So how do children work out where the words are? It has not until relatively recently that we discovered that even very young infants are using sophisticated strategies to track how different cues combine and distributed across speech. in a process called statistical learning. Safon et al. 1996. Consider the phrase happy dog. E. The basic idea is that infants are able to track how often the individual sounds ha and p, p, and dog, dog, and ie occur. Together, overall, the speech they have the sounds p and dog have a much lower probability of occurring together than do ha, p, and so this might signal a boundary between words. Repeat this process over days, months, and years for all of the sounds in the language, and infants begin to understand where the words are. Experimentally, researchers have shown that infants are instinctively using strategies like these right from birth, e.g. Phibb et al. 2019, and descriptions to statistical learning processes may underpin neurodiverse pathways of language use, such as development language disorder and dyslexia, explored further in Chapter 16, Saffron, 2018. Figure 4.1. This spectrogram is a recording of a male saying, "Oh, say can you see by the dawn early light." Source, Monson, B.B. Hunter, E.J. Lotto, A.J., and Story, B.H., 2014. The perceptual significance in high-frequency energy in the human voice, front, Cycle 5587, Do. This is an open access article distributed under the terms of the Creative Commons Attribution License. Children are remarkably adept at segmenting speech, despite huge variation in the phonology of the world's languages. That is, the system of sounds they use. For example, Ibix, once spoken around Turkey, had a few to two vowels. Rotokas, spoken in Papua New Guinea, has a few as 6 consonants, while the language with modern-day speakers in Botswana has around 31 vowels and 77 consonants. Languages also show significant differences in the sounds they will allow to appear together. For example, are not acceptable combinations in English, but they are in various Slavic languages. For example, which means clunk or flop, and which means welfare. In one way, it is remarkable that children are born capable of acquiring all this diversity, indicating the incredible plasticity of the human development. In another way, it is perhaps less surprising if the goods were unlearnable by one generation of children than they would be there in the language for the next generation of children to learn them. This flips things around from the way we usually think. Instead of just asking how children learn language, we should also ask how languages evolve to be learnable by children. Compared with adult-to-adult speech, child-directed speech is much more likely to contain high levels of repetition and more words spoken in isolation, to have a slower rate of speaking, and to use a smaller range of words, all of which also helps children get an early foothold in the language. While this way of speaking to the children might help scaffold their language development, it is far from universal, and it interacts with local childcare customs and parental beliefs. For example, Coquette mothers from Kenya believe that children learn to talk more by listening to other children than their parents, and consequently, they talk less to their 2 and 4 year old children compared with the American mothers, Super and Harkness, 1986. Key points. Children are powerful pattern detection skills to segment speech streams into words. Child-directed speech offers an important way from adult to adult speech and has been shown to help language learning.